Welcome to the presentation on Spaceborne Transmitter Stationary Receiver, a monostatic and bistatic dual polarimetric investigation. We have divided the presentation into three main parts related to the topics of data acquisition, where we'll schematically discuss the Spaceborne Transmitter Station Receiver geometry, then a few words on data visualization, which here refers to a preprocessing stage allowing a rapid inspection of the multipolarization data. And thirdly, data processing by using the dual-pole entropy alpha algorithm for both monostatic and bistatic images. The bistatic acquisition is possible with the help of a ground-based receiver and the Sentinel-1 C-band SAR instrument as transmitter of opportunity. Moreover, the monostatic data is easily accessible thanks to the free open source policy of the Copernicus Hub. For the zone of interest, Sentinel-1 uses the interferometric wide swath acquisition mode with vertical transmission, vertical and horizontal reception. As a result, it is possible to acquire a set of dual-pole data with two complementary viewpoints, spaceborne monostatic and ground-based bistatic. This offers an interesting and unique opportunity for further polarimetric data processing. Two particular constructions are useful for dual polarimetric data visualization, the Kena elements framework as well as the color composite representation. They are primary visual tools, which can be useful before the processing stage for comparison between data channels as well as between different acquisitions. The Kena elements are intensity-based and present the power relationship as well as the correlation properties between the two measured elements of the scattering matrix. For the dual-pole monostatic images, which will be used in the processing stage, the Kena elements representation on the screen is computed. It can be rapidly observed the dominance of the copolar power component as well as the subtle differences between K5 and K8, the real and imaginary parts of the interchannel correlations. The color composite is used here for visual comparison of the monostatic and bistatic acquisitions. The image containing the bistatic scene on the right may appear sparse, as observed on these images, which reveal an area located more than 5 km away from the position of the ground-based receiver. However, the antenna illumination pattern as well as the differences in the altitude location of the two imaging instruments must be taken into account. The entropy alpha algorithm, a very popular method in radar polarimetry, has been developed firstly for the symmetric monostatic use case. It has been adapted for dual polarimetry and remains at present one of the most used and cited. The figure on the right shows the changing shape of the feature space and its delimiting boundaries from bistatic to dual pole investigation, that is, from a full dimension of the coherency matrix to the reduced form of T2. Because of this dimensionality reduction, and depending on the practically employed dual-channel combination, it has been shown in the literature that some elementary scatterers may no longer have a unique mapping with respect to the alpha angle. For a comparative assessment, the decomposition method is applied only on the set of common pixels from both monostatic and bistatic data. A similar classification pattern was shown, with the vast majority of scattering points distributed in the zones of small entropy values, here in shades of blue, and only with variations in their percentage distribution between monostatic and bistatic classes. Of the entire set of pixels, a small fraction are represented in the same class for both cases. Their spatial distribution on ground, as well as location in the entropy alpha feature plane, is shown on screen. Adopting the use of improved methods, further investigations are intended for fully exploiting and understanding the capability of dual polarimetry for monostatic and bistatic data. Thank you for your attention. The live session for the current presentation will take place on the 2nd of October. For any details and further topics to explore, please visit the ESA FIWIC website.